So we have Jareth standing at 8, 1 and walking towards negative 1, 4 on some coordinate system. He's walking at constant speed. And what we know about his motion is that he reaches the point on his path that is closest to the origin 8 seconds into his journey. This detail is a little tricky to interpret. What is the question actually asking us to do? We're asked to do 3 things. We're asked to first find Jareth's speed in units per second. Then we're asked to give parametric equations for Jareth's coordinates after t seconds. And finally, we're asked, when does Jareth cross the y-axis? So if you haven't already, go ahead and pause the video and dive into those questions and see whether you can make sense of this on your own. Okay, so let's take a look at it. With all sorts of questions like this, the first thing that I like to do is draw a picture to get a little bit of a sense of intuition of what's going on. So we have our coordinate system. Jareth starts at 8, 1, which is roughly here, and walks towards negative 1, 4, which is, say, roughly here. And so Jareth's path is going to look something like this. So we might first wonder, can we find where this point in question is, this point on his path closest to the origin? You might think that this point right here would be that spot. It turns out that that's not quite true. I think the easiest way to make sense of why or how to find the point which is closest to the origin is to imagine that you were standing at the origin. Imagine that you're in a room maybe, and this path is maybe one of the walls of the room. If you were standing at the origin and you wanted to run towards the wall and run there quickly, you would certainly run in this sort of direction. And specifically, you would run in the direction that would make this meet at a perpendicular here. So if we want to find this point here, this is going to be our kind of picture that's going to help us find it. So what can we say about this point in question? Well, it's on this line, and it's on this line. So if we can write equations for those 2 lines, then we'll be able to find the point in question. So let's start with this line here. What I know about this line is, well, in order to write an equation for a line, I need a slope and a y-intercept. So let's think first about the slope. What happens as Jareth travels from his initial position to his destination? He has a rise of 3 and a run of negative 9. So I'm going to write an equation for Jareth's path. What I know so far is that the slope, what did I say? The rise was 3, the run was negative 9. I know that Jareth's path is of this form. Now, in order to find the y-intercept, all I need to do is plug in one of these points. I'll plug in, let's plug in this one. And what I find is that 4 equals 3/9 plus b. A little ugly, not too bad. I guess I'll write 3/9 as 1/3. And I could say then this is 12/3, so I'll say b equals 11/3. So I now have an equation for Jareth's path. In particular, I'll write it here, I suppose. What I come to is that y equals negative 1/3 x plus 11/3. So now what I'm interested in is saying something about this line. I know something about Jareth's path. I'm interested in this perpendicular. what do I know about this perpendicular? Well, I need, in order to write the equation for the line, a slope and a y-intercept. This perpendicular, well, it's perpendicular to this line. So I can say that the slope of this perpendicular, I'm going to have something that's of the form y equals mx plus b. It's going to be y equals 3x, and then plus b. Well, what's the y-intercept of this line? Well, it started at the origin. So I end up actually with just y equals 3x. So combining these two is going to allow me to find the coordinates for this point here. In particular, I can simply set 3x equal to this right-hand side of this equation. They're both 3x is equal to y, and this is equal to y. So the right-hand sides here are equal to each other. So what do we get when we actually go ahead and substitute this in? X is going to be 11/10. Y is, this point is definitely on this perpendicular here. So we have y equals 3x, so the y coordinate is 33/10. And let's check that when we plug this into Jareth's path, things actually behave nicely. I plug y equals 33/10 equals, and x, I get this negative 1/3 times 11/10 plus 11/3. Hopefully this will work out nicely. On the right-hand side, I have negative 11/30. And let me write this as also plus 110/30. This is going to then reduce to 99/30, which I can, in fact, now divide by 3 and find that this is 33/10. I suppose the first question it asks us is to find the speed at which Jareth is traveling. So let's go ahead and do that quickly. So Jareth starts at 8:1 and travels to this point in 8 seconds. So all I need to do to compute this speed is to say, well, how much ground did Jareth cover in those 8 seconds? So the distance between 8:1 and this point, I can think of as the square root of the difference in the x coordinates. I'm essentially just thinking of using the Pythagorean theorem or the distance formula, however you prefer to think about it. The distance in the x coordinates from here to here is 8 minus 11/10. And the difference in the y coordinates is 1 minus 33/10. So this 8 minus 11/10 is the length of this side of the triangle. This 1 minus 33/10 is the length of this side of the triangle. So the hypotenuse of the triangle, or the distance between the 2 points in question, is the square root of this. So then if I'm looking for the speed in question, the distance traveled, so I have that speed equals, I'll write it as change in distance, or I'll write it as change in position over change in time. The change in position is this d over how much time was over 8 seconds. And this was a change in just units. We don't have whether this is feet or inches or miles, but this is some measure of distance. So this is a perfectly reasonable answer for the speed, although it would be worthwhile, in addition to writing it like this, to actually grab your calculator, plug it in, and give an exact computed answer. Okay, so we have the speed. Okay, so going back to finding the parametric equations, this is really one of the biggest new ideas in a pre-calculus course. We have where Jareth is at time 0 and where Jareth is at time t equals 8. And we want to know the parametric equations for Jareth's coordinates. So what I'm looking for in particular, I'll say j of t, is I'm looking for a function that when I feed it t, it spits out, rather than just a number, it spits out a pair of coordinates. So you can think of parametric equations in a couple of different ways. The way that I'll propose to think of them here is I'm really looking for coordinates as a function of t. So maybe I'll give myself a little bit more space here. What is the x coordinate as a function of t? Well, when t equals 0, I'll make a little table here. When t equals 0, x equals 1. Oh, sorry. X equals 8. And when t equals 8, x equals 11/10. So you've a million times managed to write an equation, a linear equation, relating data like this. I personally like to think of it this way. At t equals 0, the x coordinate is 8. So I'll just start with an 8 with no t associated to it. And in 8 seconds, Jareth travels to 11/10. So how can I write this? Well, how far do you actually travel from 8 to 11/10? Well, you travel 11/10 minus 8. And what I want is to write an equation here that makes it so that when I plug in t equals 8, you will have traveled this far. Notice what happens here when I actually plug in t equals 8. It's kind of a fun little equation to work with. I'll make this a little cleaner. When I plug in t equals 8, this becomes 8 over 8. So this just becomes 1. I get 8 plus this minus 8. So the 8's disappear, and when t equals 8, I'm left with 11/10. So writing this kind of off the top of my head is something that comes with a little bit of experience. The first few times you do it, it's a little bit strange to do. Let's see if we can do it again here for y. I'll make another little table. When t equals 0, we have that y is 1. And when t equals 8, we have that y is 4. This is a little bit nicer to work with because I don't have to think about the fractions. Well, I can just write 1. And now what I want to do is I want to write something here that works in such a way that when I plug in t equals 8, y increases by 3. So this will do the trick. I guess I'll erase some of the parentheses to make it a little bit cleaner to look at. Notice what happens here. When I plug in t equals 0, this falls away, and I'm left with 1. And when I plug in t equals 8, this turns into 1, and I'm left with 1 plus 3 is 4. So here I have a solution to part B. This is parametric equations for Jareth's position at time t. And now the very final question is, when does Jareth cross the y-axis? What do we mean by cross the y-axis? We mean when is x equals 0. So this isn't so hard to work with at this point. We know that Jareth's x position is described by this equation in terms of t. So what I'm looking for is just when is this equation equal to 0. So I can just set it equal to 0. I can say when is this equal to 0, and I can just go ahead and solve. So subtracting 8 from both sides, then multiplying 8 on both sides, a little bit more arithmetic. I suppose I'll subtract 8 from both sides and multiply both sides by 8. So when I subtracted 8, I had negative 8. Then I multiplied by 8, I get negative 64. What is this? Maybe it would be easier if I actually wrote this as 80 tenths. Now I can multiply both sides of the equation by 10 to make my life a little easier. I have that 11 minus 80 t equals negative 640. I have that t, this is 11 minus 80 is negative 69. So I have t equals 640 over 69. And this is supposedly when Jareth crosses the y-axis. Does this agree with my intuition? This number is a little bit less than 10. Does it seem reasonable that Jareth would get to this spot at about t equals 10? Yeah, that seems reasonable. This was 8 seconds from here to here. My picture is apparently not quite to scale, but this certainly seems plausible that we would get there at about 10. So I feel pretty good about this answer for t. So we have our answers. That is the whole question.